Hello friends, so in this video we will be seeing with the first page replacement algorithm, that is first in first out page replacement algorithm. Okay, so let's see the working of this first and first out page replacement algorithm with a simple example. Okay, so you will be given with the reference string. Reference string is usually this is the order in which a CPU is requesting for the pages. Okay, so here we have discussed in the previous video that a process is divided into what? Pages, and these pages are stored in a main memory, and main memory is divided into a frames. Okay, so here in the main memory we have three frames which are dedicated to this process. Let us assume that this process is P1, and this process P1 is divided into how many pages? If you see this reference, which is the highest number over here, 7, which is the lowest number over here, 0. That means we can assume that this process is divided into 8 pages, right? So page number 0 to page number 7. But as you can see here, we are not having 8 frames over here. If I was having 8 frames, then I could have accommodated all this entire process at once. Okay, definitely here at some point of CPU request, we will not get that pages in the main memory. Okay. So initially, there is no page which is inserted in this main memory. So what is the first page which is requested by CPU? It is 7. So now when 7 is requested by CPU, check that. Is it there in my main memory? No. If the requested page is not there in the main memory, we term it as what? Page fault. So we will mark that page fault as with star. Okay, whenever there is a page fault, we will replace that page, or else we will bring that page from secondary memory to main memory. Okay, as all frames are empty, so I will get the page number 7 from secondary memory to main memory and store it over here. Okay, and the next frame which is requested is what? 0. Even 0 is not present over here, so I will term that as what? Page fault. Okay, and 0 is stored over there. Initially 7 was there in the frame number 3, or else you can term it as this one as frame number 1, this one as frame number 2, and this one as frame number 3 for your better understanding. In frame number 1, I have 7, and frame number 2, I have stored 0. And which is the third request? The third request is 1. Is 1 present in the main memory? No. 7 and 0 are present. 1 is not present. If it is not present, then definitely it will be what? Page fault. So when there is a page fault, okay, check is there any empty slots? Yes, I have empty slots. So store that over here. If there are no empty slots, then I have to replace one page and store and get that another page. Okay. So now what is the fourth request I am having? The fourth request is page number 2. Okay. Is 2 present in the main memory? No. If it is not present, we term it as page fault. Now the question arises, as there is no empty slots in the main memory, now it is necessary for me to replace one page and get this page number 2 from secondary memory to main memory. Now in secondary memory to main memory, if I want to get this page number 2, which is that page number I should remove from main memory and send it back to secondary memory. That is where your first in first out algorithm comes into action, right? So first in first out algorithm tells that whichever page has been first inserted, that is the one to be first removed, right? So which is the page which is inserted first? It is 7. So instead of 7, now which is the page which will be replaced? It is 2. Got it? So now 2 is replaced in the place of 7. So now 7 is done, 0 is done, 1 is done, 2 is done. Which is next which will be requested? It is 0. Is 0 present over here? Yes, 0 is present. So I term it as what? If whatever the page is requested by the CPU, it is present in the main memory, we term it as what? Page 8. So I will mark this as by H. So The frame, there is no change, it remains as it is. So which is the next page which is requested by CPU? It is 3. Check here, is 3 present in the main memory? No. If it is not present, then I will term it as what? Page fault. Okay. So when there is a page fault, it is necessary now to replace. Which is that page which I should replace? 7 is already replaced. Next page which was there is what? 0. So I should replace now 0. Instead of 0, here comes the new value, that is 3. And 1 and 2 remains as it is. Correct? So 3 is replaced now, which is the next value which is requested by CPU. It is 0. Is 0 present? No. If it is not present, we will term it as page fault. Now, you see here, 1 is replaced by not 4, 0. Because 0 is the page which is requested. Correct? Okay. Which is the next page which is requested? 4. Is 4 present? No. So here again it is a page fault. So now tell me which is that which will be replaced. See, 2 is very what you can say. It is first which is inserted, then 3, then 0. So which is the oldest one? It is 2. So this should be replaced. This should be replaced, and here instead of 2 I will mark it as the page number 4 comes in the place of page number 2. So 2, sorry, 4 is been done. After that, which is again requested, page number 2 is requested. See here, page number 2 is not present, so I will term it as what? Page fault. So which one should be replaced now? 3 should be removed out. Instead of 3, I will place it as 2 over here. Correct? So now what is the frame? What is the status of main memory now? I have frame page number 0, 2 and 4. Which is the next page which is requested? It is 3. Is 3 present? No. Then I will term it as again page fault. So now tell me in which page location this 3 should come. It is in 0th location. Right. So here 3 comes, 2 remains as it is, 4 remains as it is. Okay. So after 3, what is the request? 0. Is 0 present? No. So I will mark it as page fault. Okay. So 4 should be replaced, and here we come, we will write 0. So 0, sorry, instead of that it should be 3. Okay. So instead of 4, I will place 0 over here. Yeah, what is the next request? It is 3. Is 3 present? Yes, 3 is already present in the main memory, so it remains as it is. 3, 2, and 0. We will term it as hit. After 3, the request is of 1. Is 1 present? No, we will mark it as page fault. So 4 is replaced. Now we should replace 2. Instead of 2, I will write here 1. Okay, page number 2 is swapped from main memory to secondary memory, and from secondary memory we will get the page number 1 and I will store it in the place of 2. Correct. So after 1, what is asked? 2 is again asked. So again, if you see the main memory status, 2 is not present, so I will tell it as this is a page fault. So now the page number 3 is replaced. Instead of page number 3, I will write it as page number 2. Okay. So the last page which is requested is 0. If you see 0, is it present? Yes. We term it as hit. We will term it as hit now. Okay. This is done. So all the pages are in process. So see here, if you see how many page faults are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. So total page fault is 12. And how many hits? Page hits are how much? 1, 2, and 3. Is it equal to 15? Yes. How many pages were requested by CPU? 15. Out of 15, page hits are 3. That means 3 times whatever the request is done by CPU is present in the main memory, and 12 times it was not present in the main memory. So that is why page faults are 12 and page hits are 3. They may ask you also the ratio of page hit and page fault. So hit ratio is calculated by the formula. The hit ratio formula is what? Number of hits divided by number of references. Number of references into 100, which is equal to number of hits are how much? 3. Number of references are how much? 15. So 3 divided by 15 into 100, which is equal to how much? 20%. So hit ratio is 20%. When hit ratio is 20%, what will be your miss ratio or else fault ratio? Okay, definitely 12 times we have missed it. So it will be 12 divided by 15 into 100. We did 15, 12 divided by 15 into 100, which is equal to 80%. Okay, 80% of 100 minus 20 is how much? 80. So definitely your miss ratio will be 80%. Okay, so these type of problems might be asked in your exams over there. Okay, so that's it for this first in first out algorithm. Okay, and by this I will be ending this video. Thank you.